Today I'm going to do lab exercise number 4, which is measurement and uncertainty. And I'm going to perform the first activity in that lab. For this part of the lab, I'm going to need my balance. And I'm going to need 2 plastic cups from the lab kit. Number 1, and then this one's labeled number 2. Now these are the 2 plastic cups found from the lab kit, so I would assume that they're about the same size, shape, and maybe even mass. But we're going to determine that during this activity. So for this part of the activity, I'm going to measure the mass of each cup, but we're going to do it for 5 different times to make sure we can get an accurate average mass of the cup. So I'm going to take cup number 1, I'm going to turn on my balance, make sure it's at 0, and if it's not at 0, we can push the tare button to balance it back down. And the first reading is 9.31 grams. So I'll take up the cup, place it back on level surface, and I'll put the cup back on the balance. I got 9.31 again. So far, it's been pretty similar. Obviously, it's been the same, so it's a pretty reliable guess at what the grams of this cup is. The third time, I also got 9.31. These are very consistent readings so far. Make sure it balances back to 0. I'm going to push the tare button just to make sure it's back at 0. For the fourth reading, this time I get 9.32, which is just slightly off from the past 3 readings. For the last reading of cup number 1, I've gotten 9.34. So for the first trial, I had 9.31 grams. The second trial, I had 9.31 grams. And the third trial, I had 9.31 grams. For the fourth trial, I had 9.32 grams. And for the fifth trial, I had 9.34 grams. So although the results are very similar, there is variance. There's some variable within the measurement of those 5 different masses. So I'm going to perform the exact same thing for cup number 2. Like I said, these are from the same lab kit and look to be very similar in size and height, and I'm assuming weight. I'm going to put cup number 2 on the balance, and this one is substantially heavier. It reads 9.83. I wonder what that's from. I'm going to take that and take it off the scale and get it back to 0. Put it back on the scale. And the second time it's 9.84. I'll remove it from the scale, make sure it's at 0. The third trial produces 9.85 grams. So it's been going up 1/100th so far. I wonder if this trend will continue. Once again, 9.84. And these are all in grams. I'm going to take it back off the scale, and my scale is reading 0. And this is 9.84 again. So for trial number 1 of cup number 2, the weight was 9.83 grams. For trial number 2, the mass was 9.84 grams. For trial number 3, the mass was 9.85 grams. For trial number 4, it was 9.84 grams, and then again it was 9.84 grams for trial number 5. Now I'm going to get my calculator out of the drawer because we need to calculate the average mass for each cup. So what I'll do is I'll turn on the calculator and I'll input the 5 different masses from cup number 1. Should be 5 different readings. And I got 46.59, and I'll divide that by 5. And the average is 9.318. And if we were going to use just 3 significant digits, that would round up to 9.32 grams. I'm going to perform the same thing for cup number 2. So I'm going to clear this, I'm going to input my masses, 5 different. I get 49.2. Now I'm going to divide this by 5. And I'm going to get 9.84 as the average. And if I go back and I look at the statistics of that, I had 3 trials of cup number 2 where the weight was 9.84. And if I look back at cup number 1, I actually have 3 that are 9.3 and 1 that is 9.32. So the average is between the two of them, rounding out to about 9.32 if we're going to use 3 significant digits. Now the last part of this activity is going to call for me to calculate the deviation from the average. And so I'm going to actually use my graphing calculator from that part, and we'll end the video at this point. But so far we can see that there has been a little bit of discrepancy in the calculation of the mass of these 2 cups, which is not changing with the addition or subtraction of anything. And so we would hypothesize that the scientific equipment, here is the balance, has a variance of error just due to the different masses that it was calculating. So that's as far as activity 1 has got me, and I hope you've learned some about the different ways of factoring in error when you're doing scientific experiments. Thank you.